Okay, we're going to talk now about section 10D for mechanics, and we're going to start by reminding ourselves that scalars, things like distance, speed, time, and mass, um, these are things which have a magnitude only, and they don't have a direction. A vector has both a magnitude and direction. And we've been looking at forces as vectors. So we've sort of talked about this a little bit already. We've introduced ourselves to F equals ma in the previous section. So F equals ma works with vectors too. Okay, F being something you can use as a vector, and A being something you can use as a vector. So let's have a look at this example. So I represents east, J represents north. Okay, we know this one. That's fairly familiar to us. A resultant force of 3I and 8J. So something like that. That's what it will look like. Acts on a particle of mass 0.5 kilograms. Find the acceleration in the form pi plus qj. So if we say, well, we want to link forces and we know our mass and we want to link it to the acceleration, if we use this resultant force equals mass times acceleration, instead of finding any magnitudes and things, we could actually use our forces as vectors themselves. So we could do something like this maybe. So 3,8 equals mass. Well, mass, this is just 0.5. It's a scalar. You can't write that as a vector. So it's just 0.5. And the acceleration, well, that's ultimately what I want to find out. Okay, so that's P and Q. Well, these are our mystery numbers here that we want to find out. So what could we do? Well, we could multiply both sides by 2, couldn't we? So 6,8 is going to be equal to PQ, which will be our acceleration, in the form PI plus QJ. So you could say 6I plus 8Q. Okay, that would be the acceleration. Find the magnitude and bearing of the acceleration. So look, magnitude is a clue for Pythagoras. Bearing is something related to the angle. So we could do that now using this. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. That's what it looks like. Make sure you put the arrow on it. We want to find the magnitude. So the magnitude, well, this is 6, 8. This will be 10, okay? 6 squared plus 8 squared. And root it will be 10. Okay, so 10 will be the magnitude. And the bearing, well, you want to find this one here. So you could use tan of theta equals opposite over adjacent, 8 over 6. Find this one here, and then remember that a bearing, it's actually going to be this one here. Okay, so when you find theta from arctan, remember to do 90 minus theta, which will lead you to your answer. So see, we've got a neater version of this one. So let's reveal. So 616. Did we make an error on that one? 616. Oh, we forgot to double that one. Oh dear, that's a bad mistake. So it definitely won't be 10 because it's not a nice, neat number like that. It will give you 17 instead. And let's quickly look at it. So we got our angle. Let's see if we've got our angle here. So we do arctan on 16 over 6. So we get 69.4 degrees. And then we remember to take it away from 90. Okay. So it's 0 to 1. That's our final answer for a bearing. What else can we do? So we can have multiple forces. So we can do F equals ma. And look here, we've got ourselves 3 forces. So 2, 4, minus 5, 4, and 6 minus 5. All of these act on the same particle of mass 3 kilograms. Find the acceleration. Okay, well, F equals ma. Remember, the F stands for the resultant force. So we're going to do the result, and we're going to do the result of all of the i's. So 2 minus 5 is minus 3, plus 6, that will be 3. And the result for the j's. So that's 4, 4, so 8 minus 5, so it's also 3. Okay, the mass is 3. and then we have our acceleration that we're going to find out. I suppose you could write it like something like this, AI and AJ or something like that. Divide by 3 both sides. So we should be able to find the acceleration. Let's have a quick look at that one there. Okay, and you end up with 1, 1. So this is another form of writing 1, 1. So you could write I plus J is the acceleration. Or if you prefer, you could write it as 1, 1. Acceleration equals 1, 1 like this. Depends what the question's asking you for. Let's do another one. So a boat is modeled as a particle of mass 60 kilograms. It's being acted on by 3 forces. So we know the forces here. So what have we got? We've got forces. We've got a mass. Given that the boat is accelerating and we've got an acceleration, so we want to link this all together with F equals ma again. So what are we actually finding? Well, look, there's some missing values there. So we're going to say that the resultant force, and we're going to do the resultant force for the top number and for the bottom number, okay, is equal to our mass. Our mass will be 60. Our acceleration, well, we've got those numbers as well. 0.8 minus 1.5, and we're going to problem solve this way. So let's take a look. So the resultant force is the same as adding them all together. And if we simplify, our F can be all of this part here. Okay. The MA, well, we've looked at the MA already. We'll set that equal to it. And when you have a number at the front with a vector here, you multiply by both of these parts. So that'll be 60 times 0.8 and 60 times minus 1.5. Now you've actually got top equals top and bottom equals bottom. So you can solve your questions from here. Here's your top equation and here's your bottom equation to find these two values, P and Q. And finally, we've got one here talking about things being parallel. So A and B are two forces. Find mu if A plus mu B. So we're going to multiply this one here by mu and then add A to it as well. It's going to be parallel to this. So, well, let's do this part first. So if I rewrite B as a 1, 1, and I multiply it by mu, it's easier to see what's going to happen. It's going to turn into mu, mu. If I add A to it, well, that will be 3, and that will be minus 1. So if you add this together, you're going to get 3 plus mu, and, well, we can write it the other way around if you want, mu minus 1. So that is this whole thing here together. It's going to be parallel. Well, if something's parallel, it's a multiple of this thing here, 3, 1. So this is what we're going to solve. We're going to get a top line and we're going to get a bottom line. And that's how we're going to solve this situation because we've got two things we don't know. So let's take a look. This is in I and J form. What are they doing? They're applying, so they're doing this one to start with. They're multiplying by mu. They're grouping the i's and j's together. I mean, we're doing that by using in vector form. Are they doing something a little bit different here? Factorize the terms in I and j. Okay, no, they're just doing I and j like we did here. So 3 plus mu for the top one, mu minus 1, or minus 1 plus mu, same thing here. They've decided to go down a different route, but we could solve it this way here. In fact, let's just show you. So 3 plus mu equals 3 lambda is the top line, and then the next line is I'm going to write it the other way around here. So mu minus 1 here equals lambda. Well, if you subtract, you will get 3 minus minus 1 is 4. Mu minus mu is gone. And 3 lambda minus lambda is 2 lambda. So you will get that lambda equals 2. And you can put this number back in. Move the minus 1 here to the other side. So mu should equal 3. Start by calculating in terms of a... Okay, so let's just fast forward. This should give you the answer here. Yeah. So, well, if you do it this way, you don't even need the lambda. You end up with just mu on its own. But this is probably the way that I would handle it. Okay. This is an alternative way that you can use. I'm not going to explain that though, because this is the method that is mostly used in mark schemes. Okay, and that takes you on to section 10D.